Hello Spartans! Part 1 of my crash course on Linux terminal was all about fundamentals, but these are useless without examples. In this video I will share several commands that you must know if you want to become a cybersecurity professional. And I will also teach you how to write your first bash script. Without further ado, release the new intro.
Release the hounds.
Because we have so many commands to go over, I'm going to keep it simple. I'm going to tell you which commands and flags I tend to use and what kind of information can you expect to see. If you need to find more information about these commands and the flags, I highly recommend that you check them out by yourself as homework. We are going to start with file management using bash. As you can see on my prompt right now, my current folder is crash course, and this is under my home folder. I created this directory specifically for this video. Now, one command that is quite useful sometimes, especially when you are navigating between folders, is a command called pwd. And pwd shows you what is your current working directory. Pwd means print working directory. So in this case, if you run pwd, you can see that I'm running this command from home admin crash course. Now, the second command that is quite useful is ls, which is command that allows you to list files under a directory or get information about a specific file. When you don't pass any arguments for ls, you are going to get the file listing of the folder where your prompt is currently in. Now, the flags that I tend to use are A and L, which give me a quite verbose output for the files that are inside the directory where I am. So in this case, if you run ls/la or al, it's up to you, you get a list of all the files that I have in this folder. As you can see, we have folders, which are marked in dark blue. We have regular files, and then we have executable files. Now, you may have noticed that there are two special folders at the top, the dot and the double dot. In Linux terminology, and even in other operating systems, the dot means the current directory, while two dots means the previous directory. And when I'm in the previous directory, I'm in the directory that is above in the hierarchy. So as an example, if we do ls with the same flags but applied to the current directory, which is the one that we have just seen, you are going to see the exact same output. On the other hand, if we want to check the files that are above this crash course, which in this case is under home admin, as you can see here, we can do ls/al, and in this case 2 dots, and you are going to see the contents of the folder admin. Now, another useful command is cd, changing directory, and changing directory, you can use it to move within directories. So as an example, if we go to cd find and we do another ls, we can see that there are some files there. Now, if we do cd ... we are back to the same folder as in the beginning. If you find yourself lost and all you want to do is go back to your home folder, you can simply do cd ... and you are on your home folder. But we want to go to crash course, so now we are inside crash course again. Now, another useful command is which, and which tells you where a given binary is within the file system. So as an example, if we run which with pwd, you can see that pwd is under user bin. Up next, we have the command move or mv, and this is useful if you want to move files and folders around, or if you just want to rename them. As an example, I have one folder dedicated to this, which is called tomove, and inside this tomove, we can see that the content is just a tomove.txt, and what I'm going to do is I'm going to move it to tomove2. So as an example, we can do tomove and call it tomove2, and now we can see that tomove has been tomove2. If we list the contents of this file, we can see that the text file is there. Another example of a useful command is touch, and touch allows you to create a file, or you can use it to change the last modified timestamp of a file. And the last modified timestamp tells you when was the file last modified, as you can expect. You can see that this to be encrypted was last modified yesterday at this time. So as an example, we can do touch and create a file called touch.txt. And now if we list the files, we can see that touch was created today at 8:46. Another useful command is make dir and remove dir. And these commands, as expected, allow you to create a folder, directory, or delete one. So as an example, we can run the command make dir folder. Now if we list it, we can see that it was created. If you want to remove it, you can simply write remove dir. And now we run the command again, and the folder is no longer there. If you want to simply remove a file, you can use rm. So as an example, we can use remove to remove the file that we just created with touch. Remove touch.txt, and now if we run it again, we can see that the file no longer exists. You can also use the rm command to remove directories, in which case you should pass the flag r or recursive. And this is going to delete all the files within the directory and the directory itself. Otherwise, you are going to get an error stating that this is a directory and it cannot be removed with this command. Another useful command is cp or copy, and this allows you, not surprisingly, to copy files. As an example, once more, let's create a file called cp.txt. And then what we are going to do is create a copy of the file. So we copy the file and let's call it cp2.txt. And now you can see that there are two copies of the file. Of course, the files are empty, but if they had anything inside, some texts, the text would also be copied. It's an exact copy of the initial file. As I mentioned a couple of seconds ago, Touch allows you to create a file, but you can also create a file using Nano. And Nano is a command line editor for files. As an example, we can say nano.txt. This is going to create a file or open a file called nano.txt. If you open, you can see that this is a much less friendly interface as your usual Sublime or Word document. You can write something inside, such as an example of a nano file for CyberSpartan video. Now we can save the content, and this is where it gets a bit tricky. You have to use Ctrl-O to write, and then it's going to ask you here to confirm that this is going to be the name of the file. You press enter, and just like that, you created a file. Now, if you use the Ctrl-X to leave, and you run the next command, cat, which is the command that I was going to show you next, you can see that the content of the file is the same as I've showed you before. And I've just showed you the next command that I was going to show you in the first place, which is cat. And cat allows you to print out the content of a given file. And I'm going to use cat again later with other commands. So for now, I'm just going to skip it, but you get the idea. Up next, we have two commands. One is called more and the other is called less. Both commands allow you to open a file and see the content and then use your up and down arrow keys to move within the file. Now, the difference is that more loads the entire file in memory and doesn't allow you to move within the file with as much fluidity when compared to less, while less loads the file as you need it and then allows you to scroll line by line. And this is useful if your file is really big. In order to show you how more or less works, I'm going to use more or less HTML as an example. And this is simply the main page of google.com. So if we run more on more or less.html, you can see that big chunk of the page was already loaded, and when you move, you quickly get to the end of the page, and doesn't allow you a lot of flexibility to go up and down. Now, if you go with less, you can see that allows you much more flexibility as it scrolls line by line rather than loading everything in memory. These are useful if you want to simply scroll through the content of the file rather than dumping the entire file using cat. Another pair of commands is head and tail. And head shows you the first couple of lines of a file, and tail shows you the last couple of lines of the file. And you can choose how many lines do you want to see. Once more, I'm going to use the more or less file to show exactly what I mean. If we run add and we pass the flag -5, what is happening here is that I'm showing you the top 5 lines of the file more or less.html. If you want 6 lines, you can do instead -6. And you get the idea. Alternatively, if you want to see the last 5 lines of the file, you can run instead tail, and you get the last 5 lines of the file. And finally, we get to the most interesting part of this segment on file system, and this is where we start talking about manipulation of files and search of files. There is a command called find, which is useful if you want to find a file given a name. I created a folder called find just for this. And if I list the contents of find, you can see that there are two files, one ignore.txt and the other to be found. If I want to find a file name to be found.txt, I can simply do, and this tells me that the file is under find and to be found.txt as expected. And if you want to get fancier and you want to find all the files that end with txt extension, and starting, of course, from the folder where you are, and any subfolders, you can run this command. And this is going to list you all the files that end with txt. Once more, you can also get even more fancy, and in this case, you can use regex, which gives you much more versatility than this simple notation with asterisk. In this case, the notation is slightly different because according to regex, this dot is actually a special character, so we want to escape it. And I've talked about escaping characters before on my previous video. So if you run this command, once more, you are going to get all the files that end with txt. The final combo of commands that I want to show you is grep, sed, and awk. Grep allows you to search through files and find files with a specific pattern of characters using a regex, but it also allows you, for instance, to pipe the content of a given file to grep to see if there is a match. Sed, on the other hand, allows you to replace the content of files. And finally, awk is a really complex tool with its own language that allows you to process files with records. And this is going to become clear when I get to awk. For these last three commands, as expected, I have several examples of files. For grep specifically, I have grep.txt, which is under grep, sed, and awk folder. What I'm going to do is I'm going to run a recursive grep, which is why I have the R flag here. And this is going to search through all the files starting in the current directory, dot once more. And I'm going to look for the pattern asterisk or dot asterisk match, meaning that any file that contains match somewhere in its content. So if I run this, I can see that there is a match under grep sed awk, grep.txt with exactly the match that I'm looking for. Another thing that we can do is run grep against the file by commanding it with cat. And in this case, once more, we have a match, because as I said, grep can be used to search through files, but you can also pipe the output of a given command to grep and match. The second command I want to show you is sed, and sed allows you to replace the content of a file given an expression. I'm going to show you the initial file that I have, which contains CyberSpartan is meant to be replaced with something else. The same applies to this line with CyberSpartan. The point here is that we are going to replace CyberSpartan with something else. And what this is doing is replacing CyberSpartan with Paranoid. The S means substitution, because we said you can substitute or delete. And G means global, which means it's going to apply to all the occurrences of CyberSpartan within the file. And this is the file where we want to replace. If you run sed now, we can see that CyberSpartan was replaced with Paranoid in both instances. You can also replace the original content of the file by passing this flag here. Finally, reach awk. As I mentioned, awk operates better on records, and records can be anything such as a CSV or simply a list of fields. And to explain this properly, I'm going to show you the example that I have. As you can see here, I've put 3 records, and each record has a name, as the company, and the location. And the great thing about awk is that awk is able to split these fields really easily and manipulate them and print the output in any way that you choose. The example that I have for awk is really simple. It's a loop that is going to go through all the records, concatenate each field within the same record, and print it out to the console. And the concatenation is going to be made using a dash. Now, the code that I'm passing to awk is this one here between the single quotes. Now, bear in mind that awk acts on a per line basis, which means that the code that you write is going to be used for each line and not for the entire file. First, I'm going to assign $1 to the variable line, and $1 is actually the first field within each record. In this case, it's the name of the person. So what I'm doing here is I'm taking the first element of each record and I'm assigning it to line. Then I'm going to iterate through the rest of the elements within the same record, starting at 2, because with awk, the $1 means the first element, $2 means the second element, then $3 the third element within the same record. And then what I'm doing is I'm simply overwriting the original line with a concatenation between the old value the next record component, because this I is going to be replaced by 2, 3, etc., depending on the size of the record, and I'm concatenating them based on a dash. And then I'm printing the result. So if I run this command, you can see that the names, the companies, and the locations are printed as well, but they are now separated by a dash. Now let's talk about file permissions and ownership. In Linux, as with other operating systems, files can be read, written, and executed, for instance, scripts. And in terms of ownership, Linux sees 3 types of entities: the user or owner of the file, the group with which the file is associated, if you want more people to access the file, and the world or others. And for each one of these entities, there are permissions for reading, writing, and executing. If we go back to our original folder and run our favorite command, ls, we can see that this left side of the output shows you the read, write, and execute permissions that I just mentioned, where read is R, W is write, and X is execute. We can also see 2 names here, which happen to be admin and admin. And admin is the user that owns the file, while admin, the second one, is actually the group with which the file is associated. For each one of the entities, the user, the group, and the world, there are 3 permissions. That's why you see 2 dashes and then the permission. So this means that the world or others that are not group or the user that owns the file can read this file, but cannot execute or write. The group can read and write, as you can see here. And the user or owner can also read and write, as you can see here. Because this is a text file, they cannot execute it. There are 2 commands that are worth mentioning here that are going to be really useful when you use Linux. One of them is shown, and the other one is chmod. Shown allows you to change the owner, which is why it's called shown. Now, because we have a user called CyberSpartan that I've created before, I'm going to give you a simple example. Let's take the cp.txt and change the owner. And we are going to apply this to the file called turncoat.txt. Now, if you run this command, you can see that operation is not permitted, meaning you don't have privileges to do this. The reason is that you need sudo or to be the root to be able to change the owner of a given file. This is the security model of Linux. That means that we are going to use sudo, which is something that I'm going to talk about later. We put the password. And now if we list ls again, we can see that turncoat belongs now to CyberSpartan. We can also change the group. And if we want to change the group, we can simply run the command. And in this case, I'm not passing any user, I'm passing only a group. Because if we want to pass the user and the group, you must write it like so. But if you just want to change the group, you can simply remove this part. And now if you run it again, we can see that turncoat now belongs to the user CyberSpartan and the group root. Now the second command that I want to share with you is called chmod or change mode. And this command changes the permissions of files or directories, given one of the 3 entities that I just mentioned. Now the structure of the command is relatively simple, as can be seen on the screen, where you need to choose the user class, the operator, and the permissions. In the absence of a user class, the command is going to apply the permission changes to all the entities. As an example, you can see that processkill.sh has read, write, and execute for all the entities. But let's assume that now I want to remove executable access for all the entities. I can simply do chmod -x, meaning removing the executable permissions, and pass the name of the file. Now if I do ls again, you can see that now processkill is no longer executable by any entity. And what this means is that it's not possible to execute this script. So if I run processkill.sh, it's going to say permission denied, meaning it's not executable. What I'm going to do now is simply to run chmod once more to give executable permissions, but not to everyone, only to me, the owner of the file. So in this case, I'm going to apply for my current user +x, meaning that I want executable permissions for the processkill.sh. And now if we run the command again, we can see that now I have executable permissions while the group and the world don't. Now let's talk about processes. And for processes, I have just 3 commands for you, which I consider quite important. The first command that I have for you is top, and top allows you to check the resource usage for each process running on your device. So if you run top, top shows you many pieces of data. One of them is a process ID. The second one is the user under which the process was executed. And then you have other stats such as percentage of CPU usage, percentage of memory usage, etc. The second command that I want to share with you is process status, or PS. There are multiple flags that you can use, but the ones that I tend to use are A, U, and X, because these flags give me a more verbose output with all the users and even applications or services that are not attached to any console. As an example, just taking one example, you can see that, for instance, this command Python 3 unattended upgrade shutdown was launched by root. This is the process ID. And if you scroll to the top, you can see that this also shows you some stats on percentage of CPU used and memory. The great advantage of top is that it's live, while PS is not really live, even though you can kind of make it so. The last command I want to share with you is called kill, and it's quite useful if you want to terminate processes. Without getting into details, the operating system terminates processes by sending what is called a signal. And there are different types of signals with different codes. Some are just nudges that tell the process to terminate gracefully, meaning safe state and exit, while others are more abrupt and basically tell the process to terminate immediately, regardless of the state or without performing any house cleaning. By default, when you run kill, you are going to send the code 15, which tells the process to terminate gracefully. But let's assume now that you want to kill the process immediately, and for this you need to use the code 9, which is called sigkill. Now for this example, I'm going to launch a script on one shell, and on the other shell I'm going to terminate that script. Now if you have been following the video, we know that there is a file called process kill. And this file, all it does is running an infinite loop that prints "you can't kill me" and then sleep for 5 seconds. What I'm going to do now is I'm going to launch this script, and you can see that the first message was printed, sleeps for 5 seconds, and now it prints again. What I'm going to do now is launch a second window, and I'm going to try to find the process ID for this process that is running. Once more, I'm going to run psaux, apply a grep, and look for kill. And in this case, there are several processes. This one is actually the one that I've just ran. And the one that we are interested in is this one. And this process, the process ID is 36678. What I'm going to do now is I'm going to run kill -9. If you remember head and tail, the terminology is the same. It's a minus to pass the flag, and then you pass the kill code. And then I'm going to pass the process ID for the script. And as you can see here, the process was killed. Now we are going to talk about networking, and I'm going to start with a simple command that is quite useful for troubleshooting. For instance, if you want to find out what is your IP address, and the command is ifconfig. And ifconfig shows you the network interfaces, both physical and virtual, that are plugged to your device. In this example, we can see that there are 2 interfaces. One of them is ENS32, and this is my IP. And the second one is a loopback interface for local connections within the same device. Now, to be fair, because this is a virtual machine, these 2 interfaces are actually logical. Probably one of the most common commands that people use to test if they are connected to the internet is ping on the terminal, besides opening Firefox or your favorite browser and check if you can access Google. In this example, we can run ping with an IP. You can also use a domain, but I'm choosing an IP in this case. And we can see that I'm able to ping the IP 8.8.8.8, which means that there is connectivity. Another useful command is SSH, which unfortunately I cannot fully demonstrate here because I have not set up a SSH server to test it. But SSH allows you to establish a remote connection with a remote machine so that you can run commands on that remote machine from anywhere in the world. And the structure of the command, which you can easily find online, is something like this: SSH Bruno, which is your username, cyberspartan.com. Of course, there is no SSH server running on this domain, but you get the idea. Then you have to put your password for your username on that remote server, or you can use key authentication. Another command that is quite useful, and this has been used a lot, for instance, by pen testers, is netcat. And netcat allows you to establish a connection with a remote server that also has netcat running there, or maybe other application that is accepting connections, and you can simply send input, any input. As an example, to simulate netcat on my local machine, I'm going to run this using two terminals. This first terminal is going to host the listener, and in this case, I'm going to listen on port 9999, and the second is going to be the client connecting to this port. Now, if I run netcat with localhost, because I want to connect to my local host, and pass the port, I am now connected. If I want to send hello from the other side, you will see that this is going to be printed, because this is what netcat does. It attaches to a port and then prints out whatever input comes in. The last command I want to share with you is netstat, and netstat gives you a very good idea of which applications or services are listening on some ports or have established connections. My favorite set of flags is TAPN because they show me information on TCP connections. And to give you a good example of how established TCP connections look like on a netstat output, I'm going to open Firefox. Now that Firefox is open, I'm going to google.com, and now if I run netstat, I can see that there are several established connections by the process Firefox. The next thing I want to talk about is file transfers, because it can be quite useful sometimes to perform transfers between servers, such as uploading a file to a remote server that you own. And it can also be useful to use some commands to download web pages or files from the web. The first command that I want to share is scp. Once more, because I don't have SSH set up, I cannot really show you live, but I can show you how the command looks like, and then you can explore yourself. And scp is secure copy and allows you to transfer files over SSH. Now let's assume that you want to transfer the file cp.txt. You would do something like this, scp, cp.txt, and then you would use the same structure as the SSH command. And then you would put a colon, and in this case, I would like to save it to my home folder in the remote server. This is why I use the tilde, but you can use any path. When you run this command, you are going to transfer a file to a remote server using SSH. The next two commands I want to share with you are wget and curl. And curl is a more powerful version when compared to wget. Wget allows you to download files, download web pages, while curl allows you to download and upload, perform more complex HTTP requests, handle multiple authentication methods, and it even has a dedicated library that you can use together with your own programs. Now I'm going to show an example of a download of the main Google page using both commands. As you can see, it was stored on wget google.html. You can see the page. If we run curl instead, you can see that the page was also downloaded. These two commands are quite useful when you need to download, upload files, especially curl, or if you want to do a simple crawl on a web server. Now I'm going to talk about hashing, encoding, and encryption. As you can expect, I have some files that I'm going to use to test these commands. I have a file called encoding.txt, which says to be encoded. And here what I'm going to do, I'm going to simply do a cat, which is going to read and print out the content of encoding.txt. I'm going to pipe this output and send it to base64 to encode it using base64. And as you can see, this is how it would look like if it was encoded using base64. Now, something fun that you can do is you can pipe to base64 and then pipe again to base64, but ask base64 to decode this time. And as a challenge, you can stop the video now and try to guess what is going to come out of the other side. Okay, time is up. This is the answer. Non-surprisingly, it is the original content. Up next, I'm going to show you hashing using MD5 and SHA-256. I also have a file for this to be hashed. You can tell at this point that I'm not very creative. So I'm going to do once more hashing.txt, pipe it to SHA-256 command, and this is the result. I can also pipe this to MD5, and this is the MD5 of this initial content. Finally, I want to show you encryption, and for this I'm going to use AES 256 because it's a quite well-known standard. I'm going to use the file to be encrypted, which has the content to be encrypted, And this is the final command. I'm passing AES-256 as a cipher algorithm. I'm going to output the encrypted file to be encrypted underscore AES-256.gpg. And I'm also going to pass the flag no SIM key cache because I want to be asked a password after. Once you run this command, you are going to be asked for a password, and that password is going to be used to generate a key. And in the future, once you want to decrypt it again, you need to provide a password. So let's give it a try. I'm going to put CyberSpartan as the key. It tells me that the password is secure, but this is a test, so it's fine. Take this one anyway. And now if you do a cat on the to be encrypted, you can see that it's gibberish. Now let's decrypt the content. And this is the command. We are providing the output, which is going to be encrypted, decrypted txt. This is where the decrypted file is going to be stored. We are passing the flag decrypt, and we are passing as the input the encrypted file. So if you run the command, and now if we do a cat on to be encrypted, the score decrypted, we have the original content. The last round of commands I want to show you don't really fit in any specific category, but I find them quite useful. The first one is called watch, and watch can be used for you to run a command again and again every couple of seconds live so that you can pay attention to any changes. For instance, let's assume that you are monitoring network connections, or perhaps you are monitoring a folder to see if there are files being created there. You can use watch to keep an eye on that. So as an example, we can run watch ls all, and this command is ran every 2 seconds. Now I will show you an example. If I create a second terminal and I go to crash course, and now I create a file gotcha, and you look to the left, you can see that gotcha appears here. The second command is echo. It's a classic. It allows you to print something to the terminal. Hello. You can also use echo to pipe a string to another command. For instance, echo hello, and then pipe it to MD5 sum. And this is the MD5 of hello exclamation mark. Another useful command is history, and this one shows you the history of commands you ran on the shell. And as you can see, these are all the commands that we have executed so far. Another useful command is whoami, tells you which user are you. In this case, I'm admin. As I mentioned before, you can use package managers to extend the functionality of your operating system by installing new applications from public repositories. Each operating system has a different package manager, so it's impossible for me to cover all of them. But for instance, with Ubuntu, if I want to install, for instance, the nmap application, which is a port scanner, I can run nmap. Of course, you need sudo for this, and then it's going to ask you if you want to install it or not. In this case, I'm going to say no. This is just a test. If we use OS X, you can use a package manager like brew to install more applications. The last two commands I want to mention are quite important, and these are sudo and su. As I've shown several times throughout this video, sometimes you don't have permissions to run certain operations. Because according to the Linux model and any operating system model, each user has different permissions, and some users are more privileged than others. If you want to become more privileged, there are two ways to go about this. Either you can use a sudo command, which elevates your privileges temporarily to a level that in the extreme can resemble the level of root, and root is the most privileged user in the Unix ecosystem. And the alternative is switching to the user root, which is disabled on most operating system distributions, and for a good reason. As an example, let's open a new window and let's go to the root of the file system. Now, let's assume that I want, as my current user, to create a file called malware. If I run it like this, malware.x, which doesn't make a lot of sense because this is Linux, but anyway, you get a permission denied because it's root of the file system. And if you run lsol, if you look at the permissions for the root folder, you can see that the root has permissions to read, write, and execute, but both the group root and the world have only execute permissions and not really write permissions. But if you want to change that, and if you want to really write that file, and assuming that your user is part of the sudoers list, which is something that I'm not going to explore in this video, you can run sudo, you write admin, and now you can see that your file is there, right here. As I mentioned before, another possibility for you to elevate privileges is to switch to the user root or to any highly privileged user. And the way you do this is using the command su. or substitute user. And in this case, because I have a user called CyberSpartan, I'm going to switch to that user, and the password is CyberSpartan, because who cares about password complexity? And now if I run UMI, you can see that my new user is CyberSpartan. If I exit this session and run again UMI, I'm admin. And with these two commands, you can elevate your privileges or switch users, which is going to be quite useful as you use Linux or Unix operating systems more and more. As promised at the beginning of the video, I will now share a script that puts together several blocks that we've discussed before. As you will see, Bash language and constructions can be quite convoluted when you compare it with simple languages such as Python or Golang. The script is going to be quite simple. I'm going to start with a list of domains, and I'm going to ping each one of the IPs behind these domains. Once I have a list of alive domains, I'm going to fetch the home page of each one of these domains and look for the word security there. So I'm inside the folder scripts, and here I have two files. One of them is the ping domains txt, and this contains several domains. Google.com, GitHub.com, Facebook.com, and a domain that doesn't really exist. And the reason for this is to show you that with the bash script, you can tell if the domain exists or not based on a ping, or at least if it's responding. Because a domain may exist and the host may not respond to a ping. It depends on the configuration on the server. Now, because I want to keep this video short, I'm going to show you the final solution, and I'm not going to write the code live. And I will add the proper commentary so that you understand each step and each part of the script. So I'm going to use Nano to open this script. Starting from the top, and I add some commentary here, you can see that I'm doing a check to see if there is at least one argument, because we expect the file containing the domains to be passed as a first argument. Now, something that may be a bit confusing to you regarding ifs on bash is the square brackets or the absence of them. Square brackets usually mean that you are performing a test. This is useful when you are running these operations such as eck, where you are checking if this value is equal to this one, or if you want to check, for instance, if the file exists, which is something that we are going to check next. For all other constructions, especially when you are checking the code that returns from the execution of a command, you don't really need the square brackets. First, I'm checking the number of arguments that were passed to the script using this $hashtag. And the $hashtag tells you exactly that, the number of arguments. I'm checking if it's 0, and if the number is 0, I'm going to print the proper usage of the script, meaning that I expect the name of the script, which is obtained by accessing the variable $0. This is the name of the original script. And then I'm going to add this extra string stating that I want a domain file, a file containing the domains. And then I'm going to exit because I don't want to continue, and I exit with a code 1, meaning there was an error. Let's try to run this script without an argument, and you will see that I'm printing usage. This is the name of the script, the command, the first part of the command, and this is what I expect, the domain file. Up next, we are going to check if the domains file exists. And for this, we are going to also use a square brackets if, which is going to run a test. And the test is going to leverage this -f to test if the file exists. The argument for this is the $1, which is the first argument. In this case, it's going to be the domains file that I'm going to pass. And this is a exclamation mark that tells you not. What this line says is essentially if the file does not exist, then we echo file not found with the name of the file that we passed as an argument, and we exit. The reason why I use the exclamation mark is that we want to do a if does not instead of if it does exist, because we want to exit if it doesn't exist, so we use an exclamation mark. We are going to run the script again, and then we are going to pass the file does not exist.txt. And as you can see, it says file not found, does not exist. So the script terminated. Now let's get to the main logic of the script. The first part of the logic is pinging the IPs behind the domains to check if they respond. And then we are going to collect a list of IPs that respond so that we can use them on the second part of the logic, this part right here. We start by creating an array of domains, which is empty. It is going to be updated as we run through each of the domains to see if the IPs are alive. And we get these domains by reading the original file that we pass as an argument. As you can see here, I'm reading the file by accessing the $1 placeholder. This is going to read the entire file and pass it to the read command. And the read command is going to read the file line by line and assign each line to this domain placeholder. Now, IFS and R, these two constructions, the IFS being set to empty and the -R are used to make sure that the shell does not remove any empty fields or split each line even further. We want to read the entire line without extra splitting or extra parsing. And this is a preparation that you usually see when you are reading a file line by line. Up next, we are going to run the ping command, and the ping command is going to send only one ping per host and is also going to wait just 1 second before it times out. The argument is domain, and we are going to send the output, the standard output and the standard error to the same place, dev null, because we don't want to see any output from this command. Up next, what we are going to do is checking the output code from the previous command. And if you remember from my previous video, this construction returns you exactly that. The $? A code of 0 means that it was successful. In this case, means that there was a response from the server. Otherwise, it's a 1 or any other value. And in that case, we don't want to keep the domain. We want to move forward and ping the next domain. If the domain is responsive, we are going to echo responsive domain and the domain. And then we are going to add this domain to the array of valid domains using this construction right here. This is the proper construction because when you pass the parentheses and the domain inside, you are essentially saying that this is an element of an array. Once we have the array of valid domains, it is time for us to move on to the next step, which is getting the home pages of each domain and performing a grep to see if we can find the security string somewhere there. We start with a for loop, and in this case, we are doing a for domain in and this gibberish that you see here. Now, this gibberish is actually an expansion of the array. What we are saying essentially here is that the domain is going to be assigned each one of these domains inside that array of domains each time the loop iterates. Then what we are going to do is we are going to perform a wget, and because we don't want to store the page locally, we just want to use the content of the page for a grep operation, we are going to pass the argument -qo-. And this basically says that I want to output the content of the page to the standard output. Then what I'm going to do is I'm using a pipe because I'm going to read from the previous command and I'm going to apply a grep. And the grep is going to look for the string security. Q means quiet, meaning that it's not going to print any matches. And I is used to do a case-insensitive match, meaning it doesn't mean how security appears. If it's a capital S or not, it's still going to match. And if it matches, I'm going to print page match found for domain and the domain here. And this is the end of the loop. Now let's test the entire script. I'm going to run ping tests, and I'm going to pass the domains. And as you can see, Google, GitHub, and Facebook are responsive. The other one is not. You will notice that it's not timing out after 1 second. And the reason for this is that the timeout is for the ping, not for the name resolution. And because the domain doesn't exist, it's not going to time out after 1 second. It's going to take a bit longer. And as you can see, GitHub actually has security somewhere in the main page. So let's confirm that. We are going to perform wget, github.com. It's saved on index. So I'm going to do index.html and grep security. And as you can see, security appears in many places on GitHub's main security page. Maybe this is a good sign. It's a sign that GitHub is secure, but who knows? And that is the end of our crash course, Spartans. And that is it, Spartans. You are now ready to go out there and kick some serious ass using Bash. This skill will be invaluable if you become a cybersecurity professional. Until next time, stay safe, stay paranoid.